Momentum and problem solving. Okay, this question should be review from our previous class. Which one of these has the most inertia? So, because for inertia, the actual velocity doesn't matter, the object here that has the most mass is D, the cafeteria. Because it has the most mass, we can infer that it has the most inertia. Okay, we talked about momentum based on the article we read over the weekend. You show me your responses. You told me what you thought. Most of you thought it was fairly interesting. And then you show me the equation you wrote for the third question. All right, then we talked about momentum. From the article, we know momentum is proportional to mass and velocity. Now, we didn't know if there was a coefficient in there. Turns out the coefficient is 1. Momentum is just equal to mass times velocity. We write momentum as a lowercase p. The units for momentum are kilograms meters per second. This is a compound unit, but there's no special fancy name for it. Because velocity is a vector, so is momentum. Momentum is always going to be in the same direction as my velocity. Because mass is just a scalar, it does not change the direction. So, using that new equation, which of these has the largest momentum? Now, here we're only talking about the magnitude. We don't know anything about a direction. And this is going to be in the frame of reference of the surface of the Earth, wherever this object is. So, I know the Earth is actually rotating, but we're not talking about angular momentum or rotation momentum here, just linear momentum. Okay, so for items B and D, there is 0 velocity, so 0 momentum. Tightrope walker is probably going pretty slowly. So here we're back to a pickup truck and a dog. They're both moving and they both have mass. So the pickup truck has more mass for sure, and if it's traveling down the highway, we can make the assumption it's probably going faster than the dog. Unless, of course, it's on Highway 290, in which case its momentum is probably 0. Okay, some quick facts about momentum. These won't be on the test, but they're kind of interesting. Momentum is a fundamental physics quantity. In fact, in quantum physics, it is even more fundamental than either mass or velocity on their own. You can see this in Heisenberg's uncertainty principle. Sir Isaac Newton called momentum quantity of motion. Now, to me, that's not very robust. So, actually, Leibniz, who developed calculus about the same time as Newton did, he used the term progress to talk about what we call momentum, which he defined as the quantity of motion with which a body proceeds in a certain direction. To me, that's a lot more robust. That gives it both a mass, which is a body, and proceeding in a certain direction, which actually makes it the velocity, because that is both a magnitude and a direction. Whereas Newton was maybe not all the way there. Okay, we used this class to review our problem-solving strategy. Very quickly, all right, I'm going to go through this. This is our guess method of solving problems. G stands for given. What do I know from the problem? Both stated and implied. What unknowns are there? What's the question really asking me to solve for? Equations. Do I have the right equations? Do I have to combine 2? Or maybe more? It probably won't be more than 2. Then you substitute, you put your givens into the equations, and you solve. Don't forget your solution has to have units. We walked through sample problems. All right, the momentum of a 23 kilogram cannon shell going 530 meters per second. Mass times velocity, and we got a number. What speed must a 5 kilogram object go to have 24 kilogram meters per second momentum? With this one, we talked about being able to round off what the answer is in your head. So 24 divided by 5 is going to be a little less than 5. And the last one, finding the mass. There were only 3 variables, and so we solved for each in a different problem. Your homework, there's none due tomorrow. Don't forget your projects are due next Wednesday, and your mastery quizzes are open until next Friday at midnight.